Hello everyone, myself Joydeep, and I'm recently trying to understand how given a conformal coordinator, we can extract the flat space physics around a bulk point. And I'm going to share my screen here. So this is a work in progress with Simo Karen Huo and Kevan Namju. The idea is that we are looking at general bulk geometries, which asymptote to Poincare ADS. These geometries are of this form. They include excitations about empty ADS, as well as planar black hole geometries. What we are trying to do is to understand how given a boundary operator, if we smear them using a Fourier transform, as well as a Gaussian weight. So what happens is this kind of an operation is sufficient to extract the physics of flat space scattering near the bulk point. It's a very simple operation and it's quite surprising. So the idea is that we propose a dictionary between the bulk operators and flat space oscillators near this point. On the left-hand side are the oscillators which I just defined in equation 4, and on the right-hand side are the A's and A daggers, which are the bulk oscillators. The claim is that if we take a bunch of these mirror operators on the CFT correlator, we get something which looks like the flat space amplitude. So how we do these computations is that we take this CFT correlator, we decompose it into a product of bulk to boundary correlators, and we evaluate these bulk to boundary propagators using the WKB approximation. So at the leading order, what we get is a phase, and an integral over all these phases, it gives us the flat space delta functions. So that's the main punchline here. Now our work, it not only it's valid for 2-to-2 scattering processes, which are these in-out scattering processes, but also it goes to the, but it's also valid for different inclusive amplitudes. For instance, one of these figures is on the right, where we have some different time ordering. Okay, so now the idea is that given this bulk point, there are these nice geometric shapes which are called these boundary hyperboloids. They are causal to the bulk point. So if you shoot some light ray outwards from the bulk point, it will reach the boundary along these shapes. And the claim is that since the first order WKB approximation is really a statement about the variation principles, small bulk variations could be translated to physics of the boundary variations. So if we can understand some aspects of bulk causality, like by using some properties of these boundary hyperboloids. Our work is not only valid for these massless particles, so first of all, we can look at these current correlators as well as stress tensor correlators on the boundary using our formalism, but also we can generalize to something which is like a massive photon or massive scalar or a linearized massive graviton. The physics is a bit different here. The idea is that you, instead of the geodesic which is connected to the boundary, you first tunnel and then you start resembling a geodesic in the bulk. So these are some aspects which I hope to cover in my poster. So thanks a lot, and feel free to visit my poster in case you want further details on this. It's quite an interesting area. I think there is a lot of progress which is to be made here. Thanks a lot.